Good morning, guys. I hope you're having a happy Sunday. That's what day it is for me. I'm trying to get this video done and out to you so I can put the assignment on. We are going to be doing some review of scale factors and scale drawings and scale models for you today. We've already done conversion factors and we've done a review of proportions and solving proportions. And so what you need to know about scale factors is they're very similar to conversion factors. Essentially, they are a type of conversion factor. What you're trying to do is come up with a scale factor that you can use to discover measurements of either your scale drawing or model or your actual on the ground measurement of what your drawing would be or your model measurement would be. Okay, so let's just kind of give you a definition of what these things are right now. So scale drawing is a proportional, dimensional, two-dimensional drawing of an object. So it's obviously just a drawing. It's not actually a physical object that has three dimensions, whereas a scale model is a proportional three-dimensional model of an object. Okay, so that's kind of the difference between those two things. So what I want you to think about on a proportion is that we're going to come up with, for our scale factor is we're going to come up with some ratio or proportion that will work for us to multiply and find out our dimension that we're looking for. So typically this means that we're going to have our drawing measurement over our actual, okay, in our ratio. And the same for the model, we're going to have our model measurement over our actual. And I'm going to show you a couple of examples of this here in a minute so that you can see how it works. But when we... All right, guys, so as we look at some examples about creating scale factors so that we can find missing values, whether it's a measurement on the scale drawing or an actual measurement on the ground. We're going to look at some examples here. So this particular example asks, what is the actual distance D between Cadillac and Detroit? So the first thing we have to kind of think about is where is Cadillac and Detroit? So I see that Detroit is right here. And I see that Cadillac is right here, okay? And so I'm going to, then my next question is, what is my scale on this map? Every map has a scale, and I know you guys use your phones a lot and Google Maps, but if you're looking at a map, a hard copy map, it's going to have a scale on it. It says 1 centimeter to 50 miles. So this is what you're going to use. So your dimension on your scale drawing is 1 centimeter, and your actual dimension for every centimeter is 50 miles. So when you're setting up your ratio, you're going to have the drawing measurement on the top and the actual measurement on the bottom. Now, we're going to use that to find the actual distance between Cadillac and Detroit. So first, we're going to use a centimeter ruler to find the distance on the map between Cadillac and Detroit. That's step one. Okay? Second, the map distance is about 3.5 centimeters. So if we're measuring just as the crow flies, the map distance is going to be 3.5 centimeters from here to here. Okay? We're going to use the scale to write and solve a proportion. So we're going to set up our scale to write and solve a proportion. So here's our proportion right here. So as you can see, our ratio for the scale is right here. 1 centimeter divided by 50 miles. Okay? 1 to 50. You can see here 1 to 50. As we read this colon right here, we read it as 2. 1 to 50. 1 centimeter to 50 miles. So for every 1 centimeter, there's 50 miles on the map. And we know that that map distance is 3.5 centimeters. So we're going to put that on the top here on the right side of our proportion. And our unknown is the actual distance. Okay, so again, the drawing measurement over the actual, and on this side, the drawing measurement over the actual. Finally, we're going to use our cross products property to solve for D. So what I wish they would show you when they do this cross products property is what happens to your units, okay? So if we think about, we're going to multiply D, we're going to multiply both sides by D miles, so that gives us D miles times 1 centimeter over 50 miles. Then we're going to multiply both sides by 50 miles. So we're going to get, on this side, 3.5 centimeters times 50 miles. But we still have this 1 centimeter here. D miles times 1 centimeter, right? And so we're going to have to divide by that 1 centimeter. When we divide by that 1 centimeter, we had 3.5 centimeters over 1 centimeter. Those units are going to cancel. So even in this situation, it's a really great thing to keep track of your units, because if we're measuring an actual distance, we want to end up with miles on the ground, not centimeters. And so if you keep track of your units, you will be able to see that what is left on this side. Okay, so let's take a look at this problem. This problem is actually focused on a model of the Earth. And while we are looking at a two-dimensional drawing of that model, they do show us the different layers of the Earth. They show us the solid inner core, they show us the liquid outer core, they show us the mantle of the Earth, and then finally the crust. And so they create a drawing that helps us understand the three-dimensional nature of this model. So the question is, the liquid outer core of Earth is 2,300 kilometers thick. A scale model of the layers of Earth has a scale of 1 inch to 500 kilometers. Okay. How thick is the liquid outer core of the model? And so one of the things to think about here again is that the model measurement in our ratio is 1 inch. That's going to go on the top of your ratio. And the actual ratio is 500 kilometers. That's going to go on the bottom. And actually, let's take a look at how they do this problem. So the first thing that they do is they set up their proportion. And so here's our measurement of 1 inch to 500 kilometers. So the model to the actual. And then here we set up what we don't know, which is our model thickness of the liquid outer core of the Earth. But we know the actual thickness, which they told us was 2,300 kilometers. So we can set up our proportion to solve for our unknown, whether or not it's an unknown on the model or an unknown in the actual sense on the ground or in real life. Okay? So then we would use what we know about solving for a missing value, multiplying both sides by 2,300 kilometers. This is using the multiplication property of equality, which you all know how to use that. So what we see here is our units cancel, and I like this one because they are showing you what happens to your units, and of course the units cancel here too, and you're left with X inches on the right side. And of course we're looking for the model thickness, which is going to be in inches, so that's a good thing, right? So then we just simply do the math. Well, we can put this 2,300, this 2,300 over a 1, we multiply our numerator times our numerator, our denominator times our denominator, which is 500 times 1. And we end up with the value on the left side is in inches, which is what we really need it to be. Okay? And it's 4.6 when you do it and run it through your calculator. Okay? So in a nutshell, that's a review of using scale factors to help you solve for missing information in your work, whether it's